Hi everybody. Today I will be going over learning target 11, which is about calculating derivatives using implicit differentiation. So let's jump into it. So when I see implicit differentiation, that means we're going to be taking a derivative implicitly, and that may not mean a whole lot to you right now, but explicit differentiation is when we have y equals something, and we find the derivative of that. But in this case, we have a y here and a y here. So we can't really put this in a form where we have y equals something. Instead, we have to solve implicitly. So first thing we're going to do is we're going to take the derivative of both sides in terms of x. So I'll have d dx of y to the 4 plus xy. That's equal to the derivative with respect to x of x cubed minus x plus 2. Okay, so now let's evaluate these. So the derivative with respect to x of y to the 4th. First, we'll take the derivative using the power rule like we typically think of it for y to the 3. But we need to multiply by a y prime. Basically, that's the chain rule. Since y is a function of x, and we're taking the derivative with respect to x, we need to add in, or multiply by a y prime. And then same with the next term. But with this next term here, we'll have to do a product rule because we have an x multiplied by a y. So first I have the derivative of x, which is 1, times the second term, which is y, plus x, and the derivative of y is just y prime. I don't need to multiply by another y prime because we already have that y prime there. And then now we look at the right side. The derivative of x cubed is just 3x squared. And I don't need a y prime because I'm not taking a derivative of y here. I'm just taking a derivative of x with respect to x. And then minus 1. All right, so now I have terms with y prime, and with x. So we need to recognize here that we're trying to find y prime. Y prime is equal to dy dx. So either one of those is an appropriate way to write it. I just like writing y primes, it's a little bit easier to write. So if we're trying to solve for y prime, first we need to do some, or I guess the source of the problem is just algebra. So I'm going to keep my y prime terms on the left. And I'm going to move this term over here because that doesn't involve y prime. And now I have y prime times something on the left, y prime times something here, and then none of these involve y prime. So let's factor out y prime on that left side, which leaves me with y prime times 4y cubed plus x. And on the right side, the same thing, 3x squared minus 1 minus y. And then finally, we can just divide over that big chunk to get y prime by itself. We'll have 3x squared minus 1 minus y all over 4y cubed plus x. And that is our answer. You do notice we have y prime in terms of x and in terms of y. Since we're solving this implicitly, that's okay. And we don't have y is not defined anywhere else. Every now and then you may be given the y in terms of x. And in that case, you could sub back in, but in this case, we don't. So we can just leave in those y's. For part B, we're asked to find an equation of the tangent line to this function at the point. And I think tangent line, I think derivative. And we have a equation of a tangent line. We're also going to need a point on top of that derivative. So m, will let that be our slope. That's just the same as y prime since that's the derivative. We want to evaluate this at the point 1, 1. This vertical line here, this just means like evaluate at this point. So going back up, putting that back in view, we can plug in 1 comma 1. So we'll just have 3 minus 1 minus 1 over 4 plus 1. And this is equal to 1/5. So that's our slope. But then to find a tangent line, we also need a point. And good thing that we're given the point 1, 1. So using the point slope form, we'll have y minus 1. That's our y value that we're given. Equals 1/5 x minus 1. That's the x value that we're given. And you can leave it like this, or you can also write it in a little more traditional way of 1/5 x plus 4/5. But either of those forms is completely fine. So I hope all of this helps. Just remember implicit differentiation. You're going to be whenever you take a derivative of some y term, you got to multiply it by y prime as well because of the chain rule. And then equation of a tangent line, we're thinking you need a derivative and you need to bring in that point. If anything else is unclear, feel free to stop by office hours.